Don't mind, will you be able to kind of field those raised hands and questions? Because I'm just going to be talking.
I sure can.
Thank you.
You're
Well, thank
welcome.
you, Charlene, and the Tennessee Stormwater Association for having us today to talk to you about green infrastructure. In this presentation, I'll talk about the basic elements of green infrastructure and why it should be a solution you're considering for your stormwater management plan. I'll touch on the different applications of green infrastructure, and I've included some case studies to demonstrate how it's being used in cities across the country to meet stormwater goals. At the end, I'll talk a little bit about funding and planning for your projects. So I would like to, first of all, say thank you to Vinny for being here today. He's the Healthy Development Coordinator for the Mid-Cumberland region at the Tennessee Department of Health. And you'll hear from him a little bit later on about the co-benefits of adding green space in communities and the positive impacts it has on community health. Vinny, I don't know if you want to say any more about to introduce yourself or if you want me to keep going.
Yeah, my work is built environment. And so the Department of Health recognizes your environment is a huge part of what determines your health. And that's the work that I do. And so there's seven of us, there's seven regions across the state. We have one of us in each region, and that's what we do all day. And partners like folks in Stormwater or partners that me and Jen have developed over this time are natural partners to the work that we do at the Department of Health.
Thank you. And again, my name is Jen. I'm LEED certified, Living Building Challenge certified, and I hold a master's in sustainability from Lipscomb University. The focus of my studies was on green buildings, specifically how to balance the built environment with the natural one, because this is something I'm deeply passionate about. I believe that in order to have healthy and thriving communities, we have to foster a healthy relationship with the natural environment. And this means changing our approach to bring nature into our planning processes. I'm not presenting today as an expert or practitioner of green infrastructure. I'm here just as an advocate of the practice. And I think the case studies that I'll present demonstrate that these green spaces can achieve your stormwater management goals while expanding green spaces in communities and extending other benefits to community members. I'm also here to present myself to you all as a resource for grant writing support. My most recent position was at a local nonprofit here in Nashville that planted trees and did riparian habitat restorations. And I found an unexpected love for grant writing, and I would like to extend those skills to help cities across the state that may not have the resources like larger cities to explore funding and to help execute tree planting and green infrastructure projects. So my hope is that this presentation will be a resource that you can refer back to when you're exploring and having conversations around green infrastructure planning. I wanted to start with this quote because I think green infrastructure is a tool that provides benefits beyond the core. I don't think it's been shown in research that green infrastructure provides benefits beyond the core purpose of managing stormwater, which I've alluded to and will explore in more detail. But green infrastructure offers an opportunity to invest in the natural environment to meet our needs and create livable and viable communities, not just for future generations, but for right now. So what is green infrastructure? There is actually not one set definition of it. It can mean different things depending on the scope and goals of a project. So for the purpose of this presentation, I thought the definition from a Nature Conservancy study was appropriate. By mimicking the naturally occurring hydrologic cycle, green infrastructure is a way to mitigate stormwater by addressing it where it falls. So by designing spaces to allow for these natural processes to occur, we're embracing that natural hydrologic process, which includes interception, evaporation, transpiration, infiltration, and detention. Green infrastructure applications have been shown to be cost-effective and successful at reducing runoff, the occurrence of flooding, contributing to reduced pollutant loads, groundwater recharge, and reducing CSOs. At the same time, these installations preserve natural habitats, protect biodiversity, promote healthier communities, and even provide economic benefits to the community over the long term. So why are we talking about green infrastructure? There's two main things I want to touch on here. One is our changing climate. This graphic is a bit outdated, but it illustrates the point. It's from a report by the National Climate Assessment. They collected NOAA data and collated it to demonstrate the number of times each state has experienced a weather event that resulted in $1 billion or more in damages over this 32-year period. You can see that the Southeast is a bit of a hotspot. On the high side for Tennessee, it's 1.3 events per year, and on the low side, it's 1.1. Additionally, a study looked at all flooding data for every county in Tennessee between 1996 and 2021 and found an overall increase in flooding events. These events put pressure on existing infrastructure systems, and as we experience heavier rain events, we're at risk of occurrences of CSOs, flooding, higher levels of pollutants in water that will ultimately impact the safety of local waterways. And the financial impacts of this can be felt not just at the wastewater treatment plant, but also for homeowners who experience storm damage, as well as local businesses like a kayak company or a fishing company that can't operate due to impaired waters. So the other thing that I want to touch on with this slide is growth. As our cities grow, land changes to accommodate that growth will inevitably occur. Tennessee is on track to lose 2 million acres of farmland by 2027. So we're replacing pervious land and its existing hydrologic functionality with more and more impervious surfaces. So planning with green infrastructure in mind can help mitigate the negative stormwater implications of growth. Originally, I had green versus gray, but I did come across a lot of studies and research that shows the benefits of integrating the two, so I changed it to and. The World Resources Institute and the World Bank were of the first organizations to recommend the use of green and gray to complement each other. While green's functionality is to infiltrate, detain, and convey water, gray is more about moving it away. And their research showed that green and gray, when used together, could meet project goals and reduce costs. And this was borne out in the New York City Green Infrastructure Plan, which estimated the cost to the city for infrastructure upgrades to be about $5.3 billion. That's with green infrastructure, which is $1.5 billion less than if they had just updated, added to, or replaced conventional infrastructure systems. There was also a green infrastructure feasibility study done for Dallas, Texas by the Public Land Trust and the Nature Conservancy, and they found that green infrastructure solutions would be 77% less costly than just upgrading gray infrastructure alone. So moving on to the benefits, there are multiple benefits to be derived from incorporating green infrastructure as a stormwater management tool, but we will only touch on a few. I'll start with those that are directly associated with stormwater management, and then we'll explore some ancillary environmental benefits, fiscal and societal benefits. So flood mitigation and water quality. Plants used for stormwater treatment mitigate flooding and improve water quality in a number of ways. Soil, plant roots, and pervious surfaces allow water to slowly infiltrate back into the ground. As it moves, these materials filter out pollutants, and the cleaner water recharges groundwater reservoirs. Plants are able to intercept rain, which slows it down, and evaporation and transpiration also contribute to less water hitting the ground. The Dallas feasibility study also found through modeling that green infrastructure would reduce overflows for all storms by between 17 and 31%, delay peak flows, which would reduce area flooding and protect nearby creeks. Lower water treatment costs. So the same functions of green infrastructure that I just described, interception, detention, evapotranspiration, contribute to lower occurrences of CSOs in cities with combined sewer systems. This reduces the amount of wastewater being sent to this treatment facility, and a World Resources Institute study in Rio de Janeiro showed that by taking a systematic and integrated approach to green infrastructure could save millions in wastewater treatment costs. And now we'll move on to the co-benefits. So air quality. Plants reduce air pollution by filtering it out of the atmosphere through uptake into roots and absorption. According to the Minnesota Stormwater Manual, air pollutants, including carbon dioxide, ozone, sulfur dioxide, and particulate matter, among others, can be removed by green infrastructure. It's worth noting here also that a 2009 U.S. Energy Information Administration study found that wastewater treatment was responsible for 92% of all nitrous oxide emissions released from the waste management sector. So by reducing the amount of water that needs to be treated, we're also lowering emissions and contributing to cleaner air. I'm sure everybody on this call knows what a heat island is, but just for a refresh, heat islands occur when impervious surfaces absorb the sun's energy and then radiate it out as heat. Trees, green roofs, and vegetation can help reduce heat island effects by shading surfaces, deflecting radiation, and through transpiration. Trees have been shown to be very effective at reducing surface and surrounding air temperatures, which we've all experienced on a hot day and wanted to stand in the shade. A Philadelphia-based study found that if the city were to meet its goal of increasing the tree canopy by 30% a year, an estimated 400 premature deaths could be prevented. And biodiversity. Biodiversity encompasses the number of species, genetic diversity, and their interaction with the ecosystem. Development has put 1 million species at risk of extinction, according to the UN. Land use changes that accompany urbanization have decreased the amount of natural space that we have, resulting in habitat loss and fragmentation. And green infrastructure offers a pathway to reestablish natural habitats and connectivity. With a focus on native plant species, these spaces can provide food, shelter, habitat, and migration corridors for native wildlife. And of course, economic benefits. Green space and healthy water bodies contribute to consumer spending through recreation, tourism, shopping, and dining. Studies show that consumers spend 12% more in shops on tree-lined streets than in those without trees. Trees can lower energy costs. The Center for Urban Forest Research found that just one tree planted on the west side of a home could reduce energy costs by 3% in 5 years and 12% by year 15. Trees also raise home values. Numerous studies demonstrate that homes with trees have anywhere from 3.5 to 15% more value than those without. And now I'll hand it over to Vinny to talk more about community health and green space.
Okay, thank you, Jen. Oh, yeah, probably knock your volume down a couple because my voice is not as soothing and calm as Jen. So if you just got blasted in your ears, sorry. So we'll get back to the soothing tones shortly. In the meantime, I spend a lot of my time at work basically telling individuals that, or helping explain to individuals how they are public health. I'll sit down with a county mayor or I'll do a presentation with a road supervisor and explain to them how they're public health. And so I thought that would be kind of valuable with you all today as well, is helping you connect how you are public health, because as healthy development coordinators, we work with all types of individuals and kind of get our fingers in the pie and all sorts of different things. And we're known as the folks who show up at these odd meetings and then we turn it into a health thing, because health is everything, health is wealth. That's why I do what I do, is because I understood that connection between someone's finances in their health, someone's sleep habits in their health, and how the environment impacts that. So what I thought I'd do is kind of go through the different facets of health, give you kind of a little public health crash course, and then help you connect back to maybe what you do or some of the things Jen has talked about or is going to talk about today that will make that connection for you. Go, okay, yeah, this is public health. So the first thing is there's 8 dimensions, 8 facets to someone's health. And so the physical, environmental, financial, occupational, social, emotional, spiritual, and intellectual health. And all those make up who you are. If you ever want to do a fun activity or maybe a revealing activity, it may not be fun after you complete it, is take this little wheel here and have it labeled. You can make it on your own, like make a little wheel and label it with all the different facets of health, and then color in each slice based on how full you feel in that part of your life. So if you felt really full socially, you have a great social network, maybe you bubble that thing in all the way. Whereas if your job stresses you out, or you're struggling with your physical health, then maybe you don't color that one in as much. And then when you finish that wheel, you actually get a nice picture of where you are with the different facets of your health, and then where you can make some changes to feel more complete. And that's an activity I've done a million times. I've done it with a million folks, and I think it's a revealing way to help you understand how complex you are and how complex the communities that you work with are, down on the individual level. So I'm going to ask for a little bit of participation here a couple times. And so the first one is physical health. Physical health is pretty easy to identify, and kind of preparing for today, I went back and watched and listened to some of y'all's previous talks, and folks are talking about how we can turn this stormwater opportunity using green infrastructure into recreational opportunities, which obviously impact physical activity levels amongst folks. So in the chat, please type in how many minutes of physical activity each week is the recommended minimum. Just give it a good guess. How many minutes per week, type it in the chat, is your guess as the minimum recommended physical activity level? Yeah, all right, here we go. We got 150, 120, 150, 20. All right, nice. Okay. Everyone's up over 100. Ooh, 210. Nice, nice. 400. I like it. Okay, so great job. 150 minutes a week is the recommended minimum, and you can obtain that in as little as 10-minute increments a day. So it is like y'all are nailing it. Like honestly, this is a healthy group. I agree. And so you can obtain that as little 10-minute opportunities. 5 10-minute walks is 50 minutes for the week. And that's truly how it gets done. And when you think about green infrastructure, green spaces, if someone has opportunities to take little bite-sized pieces of activity throughout their week, then they're more likely to be physically active. And it just makes it, we talk about all the time making the healthy choice the easy choice. And that is truly the root of the work that I do, is how can I make an environment more conducive to activity and make it the easiest possible choice. So the second one is something that y'all are extremely familiar with: environmental health, how the work that y'all do that impacts water quality, air quality, but also think about like people's personal environments, like their home environment, their community environment, their neighborhood environment. And are those environments conducive to health? Are they satisfied with those environments? So my next engagement opportunity here is type in the chat, using always, sometimes, or never, how often is health a part of community planning or development discussions in your world? So the work that you do, when you're in on those discussions, how often is health a part of that discussion? Always, sometimes, or never? Type that in the chat. Let's see what we get. Sometimes, never, some to never, sometimes, and frequently. Okay, so we're definitely shading toward the mid or the lower side of that scale. And, and that's unfortunate, but it's also very common. Health just isn't a part of that discussion typically. And that's the work that we do, is to try to make health one more piece of that discussion, and how we can talk about, because that leads me to the next piece: financial health. How someone is financially, do they have what they need to meet their needs today, tomorrow, in the future? And your community determines a lot of that. What are the jobs available? What's, like Jim was talking about, the housing situation, like what's your house worth, or are you able to afford a home in your community? Are the local businesses doing well, and how can green infrastructure assist with that? And so people's financial health is a part of what makes up who they are. Occupational health, what's your job satisfaction like? We see that a lot, tying it back to green infrastructure with these work site campuses. utilizing green infrastructure, improving employee morale, cohesiveness, shared spaces for employees to hang out. Those things help with retention. Those things help with job satisfaction, and helps employers, continue to employ people more long term so they have consistent income coming in. Social health. I think y'all have a big role in social health if you realize it or not, but using green infrastructure to create those communal spaces that are comfortable to be in. So not just a park in the middle of a roasting heat desert, but a park with shade and maybe a water feature that's a part of this green infrastructure. So it's doing double, triple duty, but it's also creating these communal social spaces where we're lacking in, especially in our rural communities where we don't have those communal spaces like we used to. And y'all are a part of that. Emotional health. So that's that stress piece. We're all stressed more than we ever been. We're all connected to more screens than we've ever been. And going back to social, we feel more disconnected in a lot of ways. And so communities creating those shared spaces helps with emotional stress. Those green spaces, also, we know that just being in the presence of green, nature, natural things, natural ecosystems improves people's emotional health or improves the resiliency where they can handle the daily stresses of life a little bit better. Spiritual health, not just are you a part of a church congregation, but are you a part of something bigger than you? And I love how green infrastructure employs these volunteer opportunities where people can work together on a shared goal for a larger purpose. And I think if we create more of those spaces that then require these volunteer opportunities, whether that's litter cleanup or invasive removal or tree planting opportunities, you're impacting people's spiritual health in that way by getting them together, making them feel like they're a part of something larger, whether that larger means I'm helping my community or I'm helping my nation or I'm helping my planet. We don't care what larger is. They're a part of something bigger than themselves. They're taking themselves for a second and setting themselves aside and doing something for others. And that's part of spiritual health. And then the last piece that y'all engage in, and I saw this in one of the Tensa talks. I can't remember how far back it was, but I watched one, and someone was talking about those educational opportunities, integrating green space with education. And we're seeing more of that. We're seeing more emphasis on children getting outside and how they learn, but also adults getting outside, adults learning in nature, adults doing bird watching. I've seen so much increase in folks participating in like bird watching or like scavenger hunts in nature. And that's an exposure thing. And it's also an intellectual development thing, not to mention just reading a book is more fun when you're outside in a comfortable environment. And so those opportunities for intellectual development and pushing someone forward, making them more whole, that's part of the work that y'all do, creating those spaces for people to do that, or those opportunities for people to do that. And then the last piece I just want to talk about was social determinants of health. That's kind of, so if the 8 facets of health was part 1 of your public health crash course, then part 2 would be the social determinants of health. And those are recognizing for a long time, hey, if you are unhealthy, it's because you are not taking care of yourself. And social determinants of health is saying, yes, individual behaviors are a part of what makes someone healthy, but also their environment and other pieces make that healthy. So about 50% of your health is determined by where you live. 40% of that is socioeconomic factors, education, occupation, income, housing, community, safety. 40% of your health is determined by your community, of which the work that you all do impacts that in many ways, as Jen has talked about and is going to keep talking about. And then 10% is your physical environment. And that's the work that I do, that built environment, access to healthy food, and access to recreational opportunities. And then the other 50% is those health behaviors, which is 30%, and then health care, which is 20%. So literally half of someone's success or failure with their health is outside of their hands. It's just what's your community like, and what is your what is your community like, and then how are you interacting with that community, and how are you doing within that community, and not necessarily, well, did you work out today or did you eat your vegetables today? That's a piece of it, but it's not everything. And so I hope that I started my work in healthcare and also in fitness. It's very much personalized work, very much that second 50%. It's very much on you Mr. or Mrs. So and so to make sure you eat those vegetables or make sure you take that daily walk because you just had a heart surgery, ma'am or sir, whoever. And then I recognized over time that it was kind of futile to work with that person over and over again on their physical health whenever their environments were so poor that it made it almost impossible for them to take a daily walk or them to access a grocery store. And so I hope that this helps you all tie back everything you do to health, make it a larger part of the discussion. And that's the work that the Department of Health is doing. But I think that's a broader, people are recognizing that where I live matters. And if I can dictate my environment a little bit, then that will then sway my behavior. Y'all have different brains than I have. Y'all have that engineering brain, and y'all can literally help assist these communities engineer environments to make positive health behaviors happen. And I think that's a really positive opportunity. And I applaud y'all and I push y'all no matter what kind of negative feedback you get, or at times when it feels like there's a lot of barriers. I hope y'all this can be one more inspiration to keep pushing for what you do because it matters. And y'all are now in the club. You can join us. You're a part of public health. We let you in. And yeah, so I will toss it back to Jen.
Thank you, Vinny. And thank you for your perspective because I'm sure that public health isn't often a topic of conversation in these talks. So I think it's nice to share that perspective. Okay, so I'm going to move on to applications of green infrastructure. There are a variety of components that provide design flexibility to accommodate a wide range of project sizes and project goals. Green infrastructure can take many forms, and the best solution will always have to be determined on a case-by-case basis because there are so many factors to consider, like the level of development at your project site, the amount of space, the type of soil, other project goals, the type of runoff that you want the green infrastructure to process, just to name a few. So the first application is bioretention or rain gardens, which are small-scale engineered areas with highly permeable soils. They're planted with native grasses, flowers, shrubs, and trees, and they collect rainwater. Because of their diversity in shapes, sizes, and layouts, rain gardens offer a lot of flexibility and are great for developed areas. They reduce runoff from adjacent rooftops, sidewalks, parking lots, streets, and other impermeable surfaces. They're most effective at mitigating water in small to medium-sized rain events, and they hold water temporarily, allowing it to infiltrate back into the ground or be taken up by plants. A journal or a study published in the Journal of American Water Resources conducted a life cycle assessment analysis on a rain garden in Cincinnati to compare its impacts to conventional infrastructure. And if you're not familiar, an LCA is an internationally standardized framework for analyzing the potential environmental impacts of a product or service by analyzing all stages of its life cycle. So material extraction, manufacturing, the use, and the disposal. The study compared rain gardens to the gray counterparts and found the rain gardens were better financially. They reduced costs by about 42%, and environmentally, probably due to the less amount of concrete being used, the environmental impact was reduced by 62 to 98%. I found this case study in Maryland where two bioretention cells, one deep and one shallow, were constructed on the University of Maryland's campus to capture and treat stormwater runoff from a parking lot. They were both effective at reducing peak flow. On average, the delay of the peak flow leaving the deep cell was 4 times that of the input, and the output value of the peak was 46% of the input. In a similar analysis, the shallow cell demonstrated similar features. The delay factor was 3.4, and a peak flow was 83%. Rain gardens are also effective at removing pollutants. They found that phosphorus and nitrate removal rates were 70 to 80%, and the lead removal rate was about 90%. And they also found that as the soil and the plants got established, the functionality and effectiveness of the rain gardens to filter pollutants increased with time. Bioswales are gently sloped, low-lying linear channels designed to convey and slow the velocity of rainwater. The vegetation, typically grass or native plants, reduces runoff through infiltration and pollutant load through vegetative and soil filtration and uptake. Bioswales are great for redirecting stormwater from surrounding impervious surfaces such as roadways or parking lots. And if you're using a series of green infrastructure installations, swales can be used as pretreatment for water being directed into rain gardens. Grass swales can be used to treat acres 1 acre or smaller, and dry and wet swales provide drainage for larger areas. So for this case study, I looked again in Maryland, where they conducted a research study to assess the effectiveness of bioswales in treating stormwater runoff from a highway. And the performance of the bioswales were compared to a typical grass median. The research team found that the infiltration capacity was 5 to 10 times higher than that of the conventional median. The swale reduced overland runoff by about 87%. The storm runoff and peak flow were reduced when rainfall was less than, 1 inch or less. And the bioswales were able to filter at least 75% of the water quality volume and did so between 87 and 97%. In terms of water quality performance, they saw significant reductions in phosphorus, but they weren't as effective at filtering out nitrogen and other pollutants. So this case study is a perfect example where they could use the swales to redirect runoff into rain gardens where the contaminants could be further filtered out. Permeable pavements are an alternative to traditional concrete and asphalt surfaces that allow water to infiltrate into the ground. Permeable pavement comes in 4 forms: permeable concrete, permeable asphalt, interlocking concrete pavers, and grid pavers. As with traditional pavement or concrete installations, permeable pavements are installed on a crushed stone aggregate bedding layer and base to provide structural support and facilitate infiltration. This is a good approach in developed urban areas where large amounts of land for stormwater collection and conveyance isn't available. And the best applications are moderately trafficked areas like local roads, pedestrian walkways, bike paths, parking lots, and driveways. One thing to note with permeable pavements is regular sweeping or vacuuming is necessary in order to prevent clogging and to maintain the functionality of the pavement. There are 2 case studies I want to mention for pervious concrete. One is in Chicago. In 2006, Chicago set out to address over 1,900 miles of alleyways throughout the city that were not connected to the storm sewer system and were prone to flooding. Since the beginning of the Green Alleys program, about 330 square feet of impervious surface has been replaced with permeable pavers, detaining about 17 million gallons of runoff each year. The second was in Shoreview, Minnesota. It's a lakeside town where they were concerned about stormwater runoff from a residential street into a nearby lake. Because of the low volume and low speed of these residential streets, they replaced 9,000 square feet of asphalt roadway with pervious concrete. While the exact measurements weren't shared and I couldn't find them anywhere, they do cite compliance with the Clean Water Act, groundwater recharge, and pollution mitigation as benefits of this project. Green streets are probably my favorite green infrastructure application just because there's so much you can do on a street. So green street design incorporates preventative stormwater controls within the design rather than leaving it to the end of pipe measures. This is important because according to the Federal Highway Administration, roads and travel surfaces present the largest pollution sources. This includes metals, combustion byproducts, automotive fluids, trash, suspended solids, all of which can pollute water. Green street designs can include street trees, planter boxes, rain gardens, swales, and permeable pavement. Special considerations should be made for trees, specifically ensuring they have an adequate amount of space to accommodate their mature size, and steps should also be taken to provide adequate soil volume and the right soil mixture for healthy root growth. Argyle Street in Chicago was redesigned as a green and complete street. They used green infrastructure to reduce runoff, CSOs, and for neighborhood revitalization. Approximately 35,000 square feet of permeable surface were installed on the curbless streetscape. Water infiltrates through the permeable surfaces and drains either through the subgrade or is directed into one of 12 infiltration planters that line the street. This has actually eliminated the need for irrigation water being sourced from the municipal water supply. And Chicago's stormwater capacity requirements are about 3,300 gallons, but this installation is able to hold 7,800 gallons. And during a typical storm event, 89% of the stormwater is diverted from the gray infrastructure system. Green roofs are vegetated rooftops which process rainwater through absorption, detention, infiltration, and evapotranspiration. Rooftops offer an abundance of square footage with which to address stormwater where it falls, which can be very useful in urban areas. Green roofs offer a number of benefits beyond stormwater mitigation. Rainwater can be stored for building use. Vegetation helps reduce heating and cooling expenses for the building and lowers the surrounding heat island effect. Plants also help bolster biodiversity, and if accessible, like the Austin Public Libraries, it creates space for the public to interact with the green roof. Typically, green roof construction consists of a multi-layer application that includes plant material, an engineered growing medium, a filter mat, drainage, and waterproofing. There are different types of green roofs. Extensive roofs have 6 inches or less of growing medium, typically don't require an engineer and require less maintenance. Intensive roofs, on the other hand, have more than 6 inches of substrate and do require an engineer. Semi-intensive roofs are a cross between the two and good solutions for arid climates, which don't really apply to us in Tennessee. Green roofs are typically more expensive to install, but similar to other green infrastructure applications, they compensate for themselves over time through stormwater benefits. They can increase the lifespan of a roof, and they improve energy efficiency and property value. These green roof installations do require, as with all green infrastructure installations, regular landscape maintenance, and careful attention should also be paid to fertilizing, because we want to make sure we're not using too much of it, as the chemicals could end up polluting the runoff from the roof. The green roof at the American Society of Landscape Architects is a demonstration roof in Washington, D.C., and it was studied to inform best management practices for reducing runoff and minimizing pollution in that runoff. Water quality and quantity were monitored for 5 rain events, and results demonstrated that the roof eliminated runoff for 77% of them. This roof didn't prove to be really good at pollutant removal. Some things that they didn't consider were they didn't compare the runoff from the green roof to a conventional one, and all levels that were measured in the runoff were within the freshwater values allowed by the EPA. A note about temperatures of green roofs. A study at the University of Central Florida found that the maximum average day temperature for conventional roof surface was 130 degrees, while the average temperature of a green roof was 91. And the green roof at the Target Center Arena in Minneapolis encompasses about 113 square feet. It captures nearly 1 million gallons of stormwater annually and has cut their annual energy costs by $300,000. We're seeing a reoccurring theme here on what green interchange brings to stormwater control, and this continues with constructed wetlands. So constructed wetlands are vegetated shallow zones that are designated to hold water and allow it to slowly infiltrate into the ground. They help control floods, offer channel protection, filter pollutants, and recharge groundwater. Special considerations for constructed wetlands include the sources of the runoff into the wetland in conjunction with the flora and fauna to prevent pollutants from entering the food chain. A thermal analysis is necessary to prevent risks to nearby cold water streams, And mosquitoes can be a concern with these. Design considerations in the EPA guide provide tips on how to design to minimize the risk of mosquitoes. One example is incorporating a permanent pool that promotes an environment where predator communities can thrive. Constructed wetlands can accept runoff from stormwater hotspots, but they need adequate separation from groundwater and should be designed to allow infiltration to occur at a slow enough rate that it can remove the pollutants, but that the wetland won't dry or flood. I had a difficult time finding a case study on constructed wetlands that provided data on the effectiveness of meeting water quality and stormwater mitigation goals. But this was interesting to me. The Arlington Stormwater Wetland Park, it's in Washington State. It's a 9-acre constructed wetland. And it not only treats stormwater, but it cleans the backwash water from the city's wastewater treatment plant and reclaimed water from the city's reclamation facility before it infiltrates or discharges into the adjacent river. And there's an additional 21 acres of this park that provides wildlife habitat and serves as public recreation space. Anytime we can preserve land in its natural form is good for stormwater. There are a few different ways to apply land conservation to green stormwater plans, all of which contribute to better water quality and mitigated flood risks. Preserving and restoring riparian buffers around streams protects water quality and biodiversity in those streams. We can purposely protect natural features like wetlands, aquifer recharge areas, mature trees, and woodlands. Conservation easements affect stormwater by limiting development on private land, and open space design is an alternative to conventional housing development that dedicates open space to preservation. Again, I couldn't find a case study with the data I was looking for, but this is an example of an open space design being used for a housing development that's just outside of Austin, Texas. This development has, you can see how it's kept the housing part and the impervious pieces densely contained in order to minimize that amount. And then 600 acres of natural space is being preserved in this plan, and it includes habitat and recreational space for residents. Maintenance. I think the main takeaway for maintenance is that there will need to be a shift in the mindset of how we maintain stormwater infrastructure. Namely, instead of occasional capital-intensive fixes, green infrastructure will require routine maintenance. I don't have a case study to quote here, but the overall feeling is that the benefits that green infrastructure provides in terms of stormwater management make it the more cost-effective solution. Properly maintaining green infrastructure installations is necessary to ensure the integrity and functionality over the long term. And as we saw with the University of Maryland parking lot rain gardens, the performance can increase when properly maintained over time. And then there are a few things that to consider when we're creating a maintenance plan for a green infrastructure project. So things to think about are the types of vegetation that will be installed, what kind of maintenance tasks will be needed, how often they'll need to be performed, what types of resources will be needed, like labor, equipment, how much time it'll take. And maintenance activities, which were in each of the tables in each of the applications, but they range anywhere from weeding to removing accumulated sediment, picking up trash, removing leaves and dead plants, checking for erosion, and overall replacing components that could become damaged or washed away. And in terms of the permeable surfaces, ensuring that they're cleaned properly on a regular basis. Planning and funding. The EPA is a great resource for information, research, and modeling to determine the best approach for a project. Their tools include SWIM for detailed modeling, a stormwater calculator, models that can help you access the impact of green infrastructure on ecosystems, watershed management, and much more. The American Planning Association had a few interesting tools that could also be helpful for information gathering. iTree allows users to identify the benefits of planting trees in communities at various scales. If you're looking for emissions data, Learn is an interactive web mapping tool that can estimate the impact of local greenhouse gas emissions. The Tree Equity Score is a great resource that I used a lot at Green Interchange. It's wonderful for assessing your tree canopy if your city isn't doing its own assessment. And I came across this Green Values. It's a stormwater management calculator that allows you to evaluate a combination of green infrastructure best practices that would best meet your project goals. And funding. As I said in the introduction, I'm here as a resource to help you with creating a funding strategy to assist with grant writing. I will work with your teams to identify funding opportunities, write and submit grant proposals. And with the state of federal funding, that aspect is probably going to be challenging, but I'm confident that there are other solutions to be found with a bit of creativity. In addition to grants, there are a few ways that you can reduce cost and secure funding for green infrastructure projects, and that includes making it a part of plans for new construction, incorporating it into water infrastructure replacement projects, which we're seeing a lot of here in Nashville, developing public-private partnerships, incorporating it into downtown improvement projects, and creating incentive programs for private landowners. I hope you found this presentation useful. I'm sorry I droned on for an hour ish. But while I would love to give you more straightforward comparisons, especially on the engineering side between gray and green infrastructure as it relates to the project footprint and the cost, the nuances that surround green infrastructure make that task impossible, but also present an opportunity because there's so much flexibility in how you can use green infrastructure to meet your project goals. So I hope I've demonstrated that green infrastructure is worth considering, and I'm here to help you all in any way that I can. And I'm sure Vinny shares that sentiment, and I've included our emails here in case you would like to reach out anytime in the future.
Are there any questions or any comments from anyone? Nothing? Okay, so I did take attendance for this. So I will be sending out PDH certificates to the folks who did attend. I really appreciate Jennifer and Vincent for being here today and doing this Tenza Talk. I think it's been really, really informative. And we were really excited to have you. Thank you so much for all being here. Let me get over so I can see your screen here. I did try to find out how I could have this be in alphabetical order, and I've tried the whole time we've been on this call to try to get that done, but that did not work out for me. But anyway, they will be sending some information over for me to send out to you guys as well. So you will receive an email either this afternoon or tomorrow with your certificate, and this has been recorded as well. So this will be also